Situation this is all about. If you can identify what the claim is, try to do that first step. Okay, so what is the claim that somebody is making in this thing? Say again, sorry. Coyotes in captivity live longer than just general Minnesota coyotes. All right. In fact, northern Minnesota coyotes. So, that's in English. To translate that into Mathish, I want you to notice something about the way I pretty much have to give you these problems. What part of that is talking about the sample? Last sentence. So none of the last sentence is going to show up in this first step. Because when do we start with an idea of what might be going on? First thing. And then what do? Go take a sample to test our feelings, right? So this has got to be all about how do we feel before I even took a sample. What was the claim? Lives longer. Can we condense that into symbols and numbers? Right? Because math people, we're afraid of these. Too many words. Not really just sound. So he claims that they live longer in captivity. So he claims that their average age, their average lifespan in captivity would be greater than
4 or 5.
Good. The normal amount that they live everywhere. How did I? Wait a minute. I did change this a little bit, didn't I? Darn it. All right. I changed this a little bit because I wanted to make more sense, and then I ended up not changing all the words. I love it. Oh, God. Okay. How did I mean this to be? Oh, if they're given more room. That's right. Okay, that's what I wanted to say. The claim is they live longer in captivity if they are given more room to roam. I like it. Okay, so some of the wording might not be the greatest because all right. This kind of makes sense why we know the mean lifespan of all coyotes in captivity, because I used to have the mean lifespan of all coyotes, period, but it's kind of like, how in the hell would anybody know that? So I wanted to make this a little more believable, right? So we do know the mean lifespan of all coyotes in captivity is that. Okay, I love it. And this last sentence should say 41 northern Minnesota coyotes that have died in captivity that had more room to roam. That's what I forgot to add in. So this last sentence should say they had more room to roam. So this whole thing is about, if I give them more room in their environment, in the zoo or wherever it is they are, what effect does it have on their lifespan? So I'm going to take a sample of coyotes that have got more room to roam to compare it. Okay, let me stop for a second. Is that decent? So the claim is that the mean of these coyotes, the mean of the population of all coyotes with more room to roam, will end up being bigger than 12.45. They'll live longer. Now, where will that go? Which one? HO or H1? H1. Yeah, H1. It kind of sucks. I wish I could remember to do this. The first few examples we're going to do, the claim happens to go here. If the claim had an equal sign in it somehow, it would have to go here. So the claim could be either one of these. It just happens to be HI because it doesn't have an equal sign. I can actually show evidence for that. I can show that something's greater, way bigger, and that would be evidence. So that's going to be H1. So what's HO? So how many tail tests is this? One. In fact, can somebody figure out what would have to be true for this to be a two-tail? We're going to do at least one two-tail later today. What would it take to be a two-tail test? Yes. The claim could be equal or not equal to, as long as the H1 ends up being not equal to. How can you be not equal to something? You could be bigger or smaller. Then it's a two-tail test. So if somewhere it said the claim was, we think it stayed the same, because that would be equals. That would go here, and then this would have to be not equal to. Or we think it's changed, which would be not equal to. That's the only time it's going to be two-tail. When will it be one-tail? When I see a directional claim. We think it's greater, we think it's less, we think it's increased, we think it's bigger, rah, rah, rah. Maybe. Okay. So it's one tail. In fact, where will that tail be? Well, it's butt. No, I'm talking about the kite. No, where's the tail on the region we're developing? Where would the tail be? Yeah, where's the sample got to end up to show evidence of this guy? It's got to go show up way up here, somewhere up there, right? The claim is it's greater. My sample has to be so much bigger to be evidence that it really is bigger. And again, I want you to really understand. If I get a 12.5 from a sample, that's bigger than this. But is it bigger enough? Because every sample is going to be different than this somehow. So just the sample being bigger than this by itself doesn't mean shit. It's got to be bigger enough to show evidence that the whole population is actually bigger. So one tail up there. Can we use z-scores or t-scores or nothing? And again, you can read through, all of this is giving away the answers pretty much, but if I were you, I would have this sucker sitting next to me as I'm doing the homework, for example. You cannot have this sucker sitting next to you when you do the test. So don't ask. So what do I check to see if I could do something? Yeah, does it say it's normal? Yes. It doesn't say it's normal, but n is 41, which is bigger than 30. So that tells me I could do something, so eliminate the nothing option. And what tells me if I can use z or t? What do I have to look at to tell which one to use? Yes, which standard deviation do I know? Don't say I know the standard deviation. That makes no sense. Which one do we know? I made it really clear. We definitely know the population standard deviation. So if you're like reading through something, you're like, I'm not sure which one it is. Sample, almost definitely. Because if it was the population, I'm going to make sure. I'm like, holy shit, I got a population. So sigma is known. What does that mean? Yeah, I can use z-scores. I only have to use t-scores if I don't know sigma. All right. So step B is old news, really. Not that old. Nothing's that old in this class. Just started a couple weeks ago. All right. Now, I haven't used this phrase yet, but let me see if you guys, based on the last thing we talked about, that if we get into this region, we can reject the null. So it's kind of like math people, again, sometimes we're not very creative, which is almost nice. What do we call the region that we rejection? Again, well, let's call it the rejection region. Okay, so this is the rejection region. If I get in there, then I can reject the null. Right? It's not to say it was friend zone. It's about what do I do with the null idea. So in this case, it's like we said, it's going to be up here. We know we can use z-scores. What am I using for alpha? Well, I'll just tell you that directly. 0.01. I can use z-scores, and it's a one-tail test. Can you guys look up what that z-score is going to be? Maybe on your t-score chart, because we're crazy. I'm always curious, does anybody still wonder how the hell we get z-scores from the t-score chart? And want to admit it? No, okay. So of course, alpha's 0.01, one tail, and then I get a z-score, I just go all the way down. So 2.326. And that's like 2.33. We've actually seen that when we were doing confidence intervals before. So this is going to be 2.326. Why did I make it positive? Because it's that way, right? So you got to be careful. The t-score chart doesn't have any negatives on it because it doesn't need to. We're the humans. We have to know when we have to put a negative on. So if my rejection region was here, I better freaking make that negative 2.326. Like this. Okay. So when I say define the rejection region, I really mean draw this picture. We have defined the region. And then I also say this evil thing. Put it into words. Which is basically what we did right here. And just to look ahead a little bit. What was this again? This is a z-score, right? So we already have a z-score. Aren't we going to calculate another z-score that comes from our sample? That's what we did here, didn't we? Right? So this is me. This is what I do. You're not going to see a lot of people do this. I call the z-score that we calculate from the sample, I call it z star, just to make it different from the z-score for the rejection region. See how? Right there. So what do we do? How do we get in there? If z star is greater than 2.326, so this is putting it into words. If z star is greater than 2.326, what the hell does that statement right there mean? If our sample is at least 2.326 standard deviations away from the middle, then I could say whoever thinks the middle is true is wrong. I can reject them. And who's the one that always thinks the middle looks to be the correct place? The null, because the null always has a equal sign. I'm hoping some of you guys see that's why we kind of developed this the way we did, so we can always kind of interpret it the same way. So if my z star is bigger than 2.326, we can reject the null and also at the same time do what? So reject what this guy says. I can support what this guy says. Okay. So these kind of problems are the perfect way to talk about statistics. There's details, there's concepts that go together. The steps, I'm never going to let the steps change. There's these 5 steps. The book tells you to use a worksheet in the back of the book. You forget about that. The book uses the calculator way too much. You use these steps when you go to do a hypothesis test. So when it says use the sheet in the back, it says screw you, booger, don't, whatever you like. You can say F you, whatever you want to do. All right, and let me just summarize what we've done so far. These are the steps that we did earlier for the other problem. What are we talking about? What can we use to analyze it? And what's going to be enough evidence? So it kind of makes sense that now we know what enough evidence will be, we go see how much evidence we got. So that's the next step is, what's the sample actually say? Right? What did we see in our sample? So what did we see from our sample? What's X bar? 10.15? Of course that was the other thing. Of course, Jeff. All right. I just got to hide for a minute. All right. Please forgive me. Screw it. I don't know if you guys see the problem. These numbers are backwards. I'm very sorry. You'll hopefully forgive me. Do you guys see that? Do you guys? All right. So I hate when I do this. I really do. I just got a little too much going on. But I tried to change this to make a little more sense in the real world, and I forgot to change those numbers. So please forgive me. Right now, I wouldn't do this test at all with the numbers given. If it's 12.45 and I think they live longer and my sample is 10, I'm not going to do the test at all. That's never going to be evidence. So please forgive me. well, actually, I don't care if you forgive me, but I sort of do. This should be the other way around. Okay? So this should be okay, maybe. This is supposed to be the explanatory part. I'm sorry. I think I looked that up to find what made sense, and then I just put it in the wrong place. I love that shit.
So if we took it as given, would that mean that
I wouldn't even do the test.
we just accept the null hypothesis?
No, we never accept the null. Because no sample can actually show evidence for the null. You just fail to reject the null. So that's going to come up here in a bit.
But we reject H1.
No, and we fail to support H1.
We just fail to support.
So what's really funny is the only things you could do, is everybody cool? That's the one change right there. Is that cool? So the X bar is actually 12.45. Just flip those around. So the coyotes live 10.15 years in captivity for every coyote. And then the sample of coyotes that have more room to roam live for 12.45 years on average. Yeah, we haven't done the z-score yet. Does that change this part at all? No. Because this part only cared about the alpha and the degree, and well, not degrees of freedom yet, that would be for t-scores. But that doesn't change. Is everybody cool with that? The only thing that changes is my means were in the wrong place. Okay. So now we can do our z-score. What's the standard deviation? 4.27. What's n? 41. And what should I do now before I go make any z-scores? Yes, because we took a sample and we're talking about sample means. I better change this before I make a z-score. So sigma sub x bar is 4.27 divided by square root of 41. So I get, it's funny, Jeff. Once you round it, it's not so evil. So 0.667. The actual number of the beast is 616. You should look that up. Anyway, they got his phone number wrong. I don't know if you guys ever heard that, but that's the truth. So now, this step right here is old news. I'm just collecting what I know from the sample. Now I'm going to make a z-score. How do I always do the z-score? My data minus the mean. Now here's the next thing on these. All right. So what we do in a hypothesis test is we do this. Okay. We assume that this number is the real middle. We're saying, okay, assuming that the null is right. And you see this happen in real life. Assuming you're right, look what just happened. You're wrong. So it's like a counterexample. So hypothesis testing is proof by contradiction in a way. We say, okay, assuming the middle really is 10.15, where would we expect a sample to show up then? Somewhere close to 10.15. So then what if we get a sample really far away? That's contradicting it being 10.15. It must be bigger than 10.15. I don't know if you guys follow. So I go into a hypothesis test assuming this number is correct. So that is the middle. That's the mean. So when I go to make my z-score, the z-score formula never changes. It is my data value, 12.45, minus the middle, which we accept to be this, divided by the correct spread, which is the 0.667. Three halves, 6.9, 3.45. What is it? 3.45. That was a really creepy sound. Sorry. All right, so did we make it far enough away to reject what the null says? Yeah, in fact, you can go, another reason why I call it Z star is you could make this very visual. Z star is there. We are deep into the rejection region. We're going to reject the hell out of the HO. Right? So right there, before I go to write my conclusion, I can say reject the null, support the high. Why? Because my Z star was bigger than 2.326. You can also look at it just by what you wrote in words. Maybe. Now, let's see if you guys can get this. What's the last thing I asked for in this part of it? Something called the p-value. Just looking at this, is it very likely that if the mean really is 10.15, is it really likely to just happen to get a sample of 12.45? Look at the z-score. Is it really likely to get there? If the mean really is 10.15, how far away is this? 3.45. Really far away. Holy shit. So is it likely to get this if 10.15 is actually the middle? No. In fact, where would you normally expect it? You know, back in the past we used to say within 2 steps. But in this problem it's actually within 2.326 steps. We're being a little more precise with our definition of unusual. Right? Maybe. So the p-value is making that more specific. Can you find the area in the tail that this makes? So right up here, if you look at it, here's the 3.45. Can you find this area? That's an old question. Can you find the area above 3.45? Of course you can. That's the p-value. That's the probability that that sample would have happened just randomly, and the mean really is 10.15.
So the area would be the probability?
Yes, as always. But what is the area above 3.45? No.
The inverse?
Yes, 1 minus that, right? Because that's the area below. So the area below this is 0.9997. So what's the area above it? So that is the p-value. Stay with me now, stay with me. I'm going to show you p-values in the wild in just a second. Maybe several seconds. Maybe a minute. Several. But that is, I really want this to make sense. How do we start this hypothesis? We said, okay, assuming the 10.15 is right. Look what we just did. We just did something. Is what we just did very likely, given that 10.15 really is the middle? Is it really likely? No. 10,000, 10,000. 3 out of 10,000 chance for what we did to happen if 10.15 really is the middle. So what's more likely? That or the middle is actually bigger? Middle's bigger. That's what's more likely. Are we 100% sure about that? No. Hell no. You're never 100% sure about shit. So this is like math that says, oh yeah, we're never sure about shit. Right? But, I mean, I feel pretty damn good. I mean, you know, that being the probability that I'm wrong, I feel pretty good. Like it. So I want you to realize we calculated the p-value after we actually got the answer. P-value is sort of like a next step after that. All right. So how do I write my conclusion? Oh my God. So I know. Coming fresh off of confidence intervals when you have to write a little statement. We have to write a statement here too. So, did we find evidence? Did we find evidence against the HO? Did we make it into the rejection? Did we succeed?
Yes.
We did. So that's how I start my conclusion. We have found sufficient evidence. 2. Okay, now, Here's the part that drives me a little insane. And I know I'm throwing a lot of shit at you. We're going to do a couple more examples of this at least today. I'm throwing a lot at you. And oh well. It's so sympathetic. Which one is our claim again? HO or H1? H1 was our claim, right? So which language do I want to use then? The one talking about H1. I mean, my conclusion has got to reference what the claim was. If somebody hires me to check out a claim, and I come back and I tell them, well, here's the opposite of your claim. I'm like, no, I want to know what's up with my claim. Tell me about my claim. So we have found evidence to do what? Well, the word you use is the one that goes along with your claim. That's how you can figure it out just on that surface. But hopefully you guys understand. We made it so freaking far away from where HO thinks is true that we did support H1, and that's what the claim was. So which word do you use? The one that goes along with the one that's the claim. Your conclusion's got to be about what the claim was. So we have found sufficient evidence to support, don't freaking say H1 here, support the claim that what? Yeah, northern Minnesota coyotes live longer if given more room to roam. We have found sufficient evidence to support the claim that the northern Minnesota coyotes live longer if given more room to roam. Right? So did we make it in there? Yes, so we did it. We succeeded. We have found sufficient evidence. To do what? Use the word that goes with the claim. Support. And then what? Plagiarize. Just write what the freaking claim is. You can copy it directly from, of course you can. Right? Can you plagiarize always? No. So in case my English, if anybody's watching this is in this case. You got to talk about the claim. Why would you have to kind of rephrase this? Just put what the claim is. Make sure it makes sense in your sentence. But just, write down what the claim was. All right, so let's try another one. Just to remind you guys, practice test is on the other side, right? Here, all right, here we go. Oh boy. Which one I want to do? This one. Look at this one. This one I really just went to town. So read through that. The one about women at the time of birth of the first child. That side. Number 1. Try to identify in Mathish what the claim is.
So it just says change. Wouldn't that be anything other than?
Exactly. So how do you think you write that in Mathish? Changed. So it's not equal to. Kick ass. So an equal to with a slash through it. no matter how many times I say this, but I'm always going to have somebody come up and say, well, 25.29 is different from 24.81, so what the shit? Right? But hopefully most of you guys would be like, what are you talking about? What the shit? What's wrong with you? It's just a sample. Every sample is going to be different. So the whole idea is it different enough to be evidence that the whole population is different? So I think you guys probably overheard what we said up here. What the claim is going to be, the mean is not equal to what? 24.81. Okay. Thankfully, this one, it doesn't matter if we got the numbers in the right place because it would work either way. Where's that go? Unfortunately, again, it goes. Why does it go into H1? Because it's got the exact opposite of what it needs to go into HO, right? What do you need to go into HO? No,
Equal sign?
you need an equal sign of some kind. And I got a not equal to sign. Holy shit, that's the exact opposite of what I need to go there. So I got to go here. And what's the opposite of not equal to? Holy crap. So how many tail tests will this one be? 2 tail. Kick ass. Because like we said earlier, not equal to. It could be greater or less. So either side would be evidence if I'm far enough away. Z or T scores. What do you guys think? Z or T? Why? Yeah, 2 things you got to tell me. Second thing is we know sigma, right? What's the first thing you should say?
And it's greater than 30?
Yes. So we know we can do something, and the something we can do is Z scores because we know the population standard deviation. So you might be able to predict that the problem on the back of this probably is going to use T scores because eventually I got to make you do that. You would be right. Now what about part C? Try to do part C. It's a 2-tail test. I'm so evil. All right, I was a little too evil on this one. I was a little evil. Can you find that?